Let's dive right into this explainer on the secure software development lifecycle. Look, if you write code, if you manage an engineering team, or honestly, if you have any stake in shipping software whatsoever, treating security as an afterthought isn't just risky anymore, it is a massive, critical point of failure. So we're going to unpack exactly why building security in from day one is really the only viable path forward for modern teams. If you've spent any time in development, you have absolutely heard this exact phrase during that chaotic final sprint before a launch. Hey, just get it working first. We'll handle the security stuff later. You know, it sounds super pragmatic when you're staring down a deadline, but as we're going to see today, it's actually one of the absolute most dangerous assumptions you can make in the tech industry. It is so easy to fall into that build first, secure last mentality, right? I mean, it's kind of how the industry operated for decades. But relying on some last-minute penetration test usually just leads to sheer panic, frantic fixes, or terribly delayed launches. The data unequivocally shows us that this old patch-later model is completely broken. So here is how we're going to break this down today. First, the broken security model. Second, the true cost of delay. Third, why developers are the front line. Fourth, the shift-left solution. And finally, the business case for security.
Let's start right off with Section 1, the broken security model, or what we call build first, secure last.
Picture this. You spend months 1 through 5 just grinding away on features, rushing to get the functionality totally perfect. Then, month 6 rolls around. You're in the final sprint, and someone suggests a penetration test. And boom, you hit an absolute wall of critical issues right on the eve of your month 7 launch day. Suddenly, your engineers aren't polishing the product at all. They're essentially acting like firefighters putting out flames on a burning server rack, all because fundamental architectural flaws were totally ignored for half a year.
Which brings us to Section 2, the true cost of delay. Because patching later really costs you.
There is some fascinating NIST data that maps out the relative cost of fixing defects, and it is eye-opening. Catching a bug in the production phase costs roughly 30 times more than catching it during the design phase. Think about that, 30 times! A vulnerability that might literally take an hour to fix in a simple code review morphs into a full week of emergency patching, severe server downtime, and highly stressful incident response once it's actually live.
And to put that 30x multiplier into a real-world financial context, IBM's 2023 Cost of a Data Breach report found that the average cost of a data breach is a staggering $4.45 million. And get this, that $4.45 million, that only covers the quantifiable costs, stuff like rework, legal fees, immediate incident response. It completely ignores the unquantifiable devastation of reputational damage and long-term customer churn that follows a breach.
All right, moving into Section 3, developers are the front line. The bottom line here is that you write the code.
If you think security is just an IT infrastructure problem, listen to this. The 2023 Verizon Data Breach Investigations Report makes it crystal clear that 83% of breaches hit the web application layer. So attackers aren't really going after stolen laptops or obscure network hardware anymore. They are directly hunting the code that you write. The moment a vulnerability is disclosed, automated scanners are sweeping the internet literally within hours. If you ship without security testing, you are actively being hunted.
Every single line of code you write is either a defense or a vulnerability. Think about how the OWASP top 10 categories map directly to your daily developer choices. Injection flaws? Well, those are your database queries. Broken access control? That's your route guards and middleware. Cryptographic failures? That just comes down to your team's encryption implementation. You aren't just building features, you are literally building the attack surface.
So what do we do about it? That's Section 4. The shift-left solution. We have to move security earlier.
Shift left gets thrown around a lot as a corporate buzzword, right? But it's genuinely a survival strategy. It just means taking the security checks that we traditionally do at the very end of a release and pushing them all the way into the earliest stages of development. We're talking about running static analysis directly in your IDE, doing threat modeling during design, and catching those nasty bugs in your CI pipeline way before they ever have the chance to become public CVEs.
Think about building a house. You wouldn't frame the walls and move all your furniture in before inspecting the foundation, right? Software architecture is exactly the same. Security is your structural integrity. You simply can't wait until you're in production to realize you left the front door wide open. Security in software has to be planned from the blueprint phase. It's the steel frame of the building, not the final coat of paint. Let's get real for a second and look at the fix-it-later trap in practice. Imagine your team writes a quick, totally unsafe Python query using string formatting for an MVP. It works, the demo goes great, and the code ships. A classic 5-minute fix is totally ignored in the name of speed. But flash forward a year later, that exact same pattern has been copied and pasted by other devs, and now you're remediating 10,000 vulnerable endpoints across a massive multi-sprint nightmare. That is exactly what happens when you kick the can down the road.
When you don't shift left, you bake security debt directly into your foundation through some highly predictable failures. Architecture gets rushed, API keys end up permanently hard-coded into your repos, input validation just gets skipped entirely because someone assumed, oh, the front end will catch it. You blindly pull in third-party libraries without checking for vulnerabilities. And the harsh reality is, you simply cannot retrofit a secure architecture onto a broken foundation cheaply. It doesn't work.
Let's move to our final section, Section 5, the business case for security. This is all about compliance and trust.
If that 30x cost multiplier we talked about earlier didn't convince you, the unavoidable legal reality of modern compliance absolutely should. Bolting security on at the end is no longer legally viable. GDPR can hit you with fines up to 4% of your global annual revenue. PCI DSS version 4 explicitly requires secure coding practices. HIPAA mandates security by design, and SOC 2 audits will ruthlessly examine your entire development pipeline. Compliance isn't optional anymore, and it completely demands early integration.
But hey, it's not all doom and gloom. The incredibly positive news here is that organizations practicing the secure software development lifecycle actually ship faster. Why? Because by building security in, you massively reduce last-minute blockers and emergency patches. You drastically lower your total cost of ownership over time. And in enterprise sales, handing over a clean SOC 2 report and stellar pen test results becomes a huge competitive differentiator. Security becomes a powerful business enabler, not just a cost center.
And that brings us to the most fundamental mindset shift that has to happen. The security team can set policies, sure, and they can run scans, but they don't write your code. You do. Every single pull request you submit is a security decision, whether you intend it to be or not. Your code is going to run in a highly hostile environment known as the public internet. Learning to think like an attacker is no longer an optional skill, it is a core competency for any modern professional developer.
Before we wrap this up, let's do a quick reality check on those two critical stats we uncovered today. Remember the Verizon report showing 83% of breaches hit the web app layer? And the NIST data proving that fixing a bug in production costs 30 times more? Those two numbers alone completely validate why the old way of building software is totally obsolete.
Which leaves us with this final thought. You have a choice in how you architect your software. You must build security in from the very first blueprint, not bolted on as an afterthought. So as you open your IDE tomorrow and get ready to write your next line of code, ask yourself, are you building a secure, structural defense, or are you just giving attackers their next open door?